graph a right triangle with the 2 points forming the hypotenuse, which we've seen. Using the sides, find the distance between the 2 points to the nearest tenth if necessary. So we are not writing these in radical form. There we go. So I'm going to start with -7, 2. So I find from the origin to the left 7 up 2. So that's going to be this point right there. Now if you want to label it as -7, 2, that's fine. You don't necessarily have to. But at least I've got the first one on there. The next one is going to be -4, -2. So I would go to left 4, down 2. Which is going to give me this point right here. Again, I'm going to label it even though you don't necessarily have to. Just trying to be thorough here. So the way that I've done my triangles is if I wanted to make a hypotenuse, I've been trying to make these purple, even though it hasn't worked all the time today. Okay, so it's kind of like driving from this location to this one, and these are streets that you got to go down, and we can only go left or right and then up and down at a time. Doesn't necessarily have to be in that order. But here's what I'm going to do. I'm going to start from this point. I'm going to go to the left, and then I'm going to go up. There is my triangle right there. And once again, they have shown us, even though we may not consider it such, but that's a right angle mark right there, showing us that we do have a triangle. So from there, because I do want the Pythagorean theorem, I've got to count the length. So that's 1, 2, 3, 4. So that's a length of 4 for that leg. And then the other leg, 1, 2, 3, boom, 3. Now, if you were nerdy like I am, then you would have Pythagorean triples memorized. This isn't really something I'm proud of. But you would know right now that this answer is going to be 5. You have to know that. Of course you don't. But that triangle, this triangle, a 3, 4, 5 triangle is a very common Pythagorean triple. So if you never see it again, that's fine. But some of you may, depending on what you do later in life. So let's use the Pythagorean theorem to figure out why this is 5. Okay, so my first leg I'm going to say is the 4, although you could make it 3. The second leg I'll make 3. And if I take the 4 to the power of 2 and add 3 to the power of 2, it's going to be the same as the hypotenuse, also to the power of 2 as a square. So, evaluating these, 4 to the power of 2 is 16. 3 to the power of 2 is 9, 3 times 3. So 16 plus 9 is going to be equal to the hypotenuse as a square. And then 16 plus 9 is going to be 25. Some of you guys, I think, see how that's going to be 5 already. But now, what I will do is square root both sides to make just the hypotenuse. Right? Not hypotenuse squared. Square root of 25 is 5. It could be -5, but we don't really care about that. So 5 will work. We just want the positive values there. So we got the hypotenuse is 5, just like I said it would be because of this Pythagorean triple. Another Pythagorean triple that's pretty common, I think it's 3, 12, 13 triangle, but I also assume you don't care. Now, just to emphasize what we saw in the last lesson, because you could do this if you wanted to, is back here, at this point, you could have typed this whole stuff into the calculator and avoid these steps. So if you wanted to, you could have just typed in the square root of, at this point, you could have taken the square roots of both sides. And you would have had the square root of 4 squared plus 3 squared. You push enter, and the calculator would give you directly 5. And it said up the top, round to the nearest tenth. It wasn't necessary, so we got to skip the rounding part.